Hi, my name is Ladewig and I'm a researcher here at the Karlsruhe Institute of Technology, and in this short video today I want to show you our latest little device that's come from the metal 3D printing facilities here at the Institute for Microprocess Engineering. So what you see here is the heat exchanger that's come from the workshop, and it has an opening at the top here where we place our membrane in. It can be an inorganic membrane or it can be a polymer membrane cut to the same size. These small holes here that you see allow the gas to permeate through the membrane and go down through the heat exchanger. What makes this really impressive, and really you could only manufacture something like this using metal 3D printing, is the fact that we can pump a cooling fluid in here and it goes through it splits out and goes through 4 tiny channels, and they are in the solid metal sections here between these gas permeation holes. And if we look from the bottom, you can just see inside there, you can see some lines running parallel. So these are these very small fluid flow channels through which the cooling water flows, and it comes out the other side here. The fitting on here has been machined so that it fits exactly into our gas permeation cell, so we can use the cell with or without the heat exchanger in place. But what this lets us do for the very first time is make measurements of the photoresponsive gas permeation properties through membranes, and have the highest degree of control over the temperature of the membrane that we've ever had before. And that's really important so that we know that any observed changes in the transport properties come from changes in the material and not just thermally induced changes in the transport properties. So we are very excited and looking forward to getting this into our membrane test cell, and we hope to share some results with you really, really soon.